Good afternoon, friends. Today our subject is continuing manufacturing processes 2, and now we are passing through module number 4, general purpose machine tools. Today's lecture topic will be configuration, kinematic system, working principle and applications of shaping machine, planing machine and slotting machines, all of which are reciprocating type machine tools. Now, what are the objectives of the topics today? The configuration and functions of shaping machine, planing machine and slotting machine. Next, the kinematic systems and the working principle of shaping machine, planing machine and slotting machine. And third, various machining applications of those machine tools. Now, let us come from the configuration. Configuration means the get up, general vision, general get up, configuration and basic functions of shaping machine, planing machine and slotting machines. And all these machines are taken together because they are basically used to produce flat surfaces, and the working principle is based on reciprocating of the cutting tool relative to the job. Now, start from the shaping machine. Principle of production of flat surface in shaping machine. Now, this is the surface, which is going to be machined. This is called desired flat surface. Now, this is produced, this is the workpiece and this is the layer of material which has to be removed, this portion. Now, this is a cutting tool, the cutting tool reciprocates like this, and because of the linear motion, forward linear motion is called the cutting motion, and the workpiece is moved in this direction, that is called feed motion. So, combination of this cutting motion and feed motion will produce the flat surface. How does it? Now, when this tool moves forward, suppose there is a layer of material is getting removed by the forward motion of the tool. So, this layer will be removed in one pass, then the tool will go back. When the tool will go back, then the workpiece will move by a little amount called feed, and then the next layer, this layer of material will be removed. So, layer by layer this entire surface material will be removed and we get a flat surface. Now, this is to be observed that there are two motions, one is cutting motion, one is feed motion. Cutting motion, there are two parts, one is cutting tool and the job. The cutting tool in shaping machine moves fast, giving the cutting motion, and the workpiece moves slowly in a transverse direction, and that is called feed motion, and resulting the flat surface. Now, what is planing machine? In planing machine, the slight difference is there. What is the slight difference? Instead of the cutting tool, the job will reciprocate, which is a large job that will reciprocate as if the tool is stationary, and then instead the job moves in this direction, the tool will move in this direction. So, relatively matters remain the same. So, this is the cutting motion given by the reciprocation of the job mounted on the table, and the tool is given the feed motion, that is the characteristics of planing machine. Now, what is slotting machine? In the slotting machine, the whole this is horizontal work, this entire work is going on, say horizontal plane, this cutting motion, all these things are horizontal plane, both the motions. But in slotting machine, all the work will be vertical, in the vertical plane, perpendicular to the surface. But the basic principle of slotting and shaping will be exactly same. So far as tool work motion, generatrix, directrix, feed and cutting motion are concerned. So often these slotting machines are called vertical shaping machine or vertical shaper, because it is nothing but if a shaping machine works in a vertical plane, the tool reciprocates in a vertical direction, this will not be nothing but a slotting machine. Now, next is configuration of basic functions of shaping machines. Now, this is a very common shape of shaping machine, which has got the main starting point, important point is this one. This is the cutting tool. Okay. This is the cutting tool and this is the workpiece. This is a cylindrical workpiece. Now, at the top a flat surface has to be cut and that flat surface will be produced by reciprocating of the cutting tool with a depth and the job will move slowly in this direction. This workpiece is mounted on a vise. This is called vise. The vise is mounted, this is the vise which is mounted on the machine bed and this is the cutting tool. This cutting tool is here. This cutting tool reciprocates. These are mounted on the head, a slide, vertical slide that is connected with a ram and this ram reciprocates. So, the result is that the cutting tool reciprocates like this and the table is holding the vise. On the vise the job is mounted on the vise and the table moves in this direction along with the vise. So, the job is moving in this direction. As a result, this is the workpiece and this is the cutting tool and this is the material removal. So, this reciprocates, this moves in this direction, feed motion and this is cutting motion. So, this is how shaping machine works. Now, tool work motions. We have told the tool reciprocates, that is called cutting motion and the workpiece that is moved slowly in the transverse direction and that is called feed motion, slow motion. What is the basic function? Very simple and this type of shaping machines or any shaping machines are used mostly for making flat surfaces in different planes. The flat surface in horizontal plane mostly, it can be in the vertical plane, it can be the inclined plane and this can be interior also in the side surface from slots and features, grooves can also be machined. In some special application, this can be used for making some small gears or few teeth of gear for maintenance purpose. These things will be told in more detail. All right. Now, come to planing machine, configuration and function of planing machine. Please recall I told that the difference between shaping and planing lies in shaping machines are small, they are used for small jobs and light cuts, but planing machines are very large machine tools, rugged machine tools. They are used for large jobs with a long cut and heavy cut with a long high depth and feed. So, this is the planing machine and this is the table. This is the table which reciprocates, this is a table which reciprocates over a long distance, you see, and the workpiece is mounted here. So, in this diagram you see this is the cutting tool and this is the workpiece. So, the workpiece reciprocates being mounted on the table. The table slides over the guide of the machine or bed, this is called bed and this is the cutting tool. So, the cutting tool moves gradually in this direction. So, the tool is given the feed motion, slow feed motion and the workpiece is given the fast cutting velocity. This is the basic difference in principle with from shaping machine. Beside that, planing machines are very large. So, the tool work motions I explained that the work moves reciprocates giving the cutting motion, fast cutting motion and the cutting tool moves slowly in the transverse direction giving the feed motion and basic function again is very similar to that of shaping machine, that is production of flat surfaces in a horizontal plane, in vertical plane and in inclined plane and little bit from side also. Beside that, some special work, some special applications are also there which will be told in appropriate time. Next, let us see the slotting machine, configuration and functions of slotting machine. I already told the slotting machine is nothing but a vertical shaper. What is shaper? In shaper, the cutting tool reciprocates, but in horizontal plane. In slotting machine, this is the cutting tool mounted in a tool holder and this reciprocates vertically up and down. And this is the workpiece, say it is a gear where a slot has to be cut like keyway, a slot has to be cut along the axis and by this cutting tool which has to reciprocate. So, here we find that the cutting tool reciprocates at high speed giving the cutting motion and the workpiece is moved either in this direction or in this direction or rotation slowly and these are called feed motions. This is the configuration of the slotting machine. This tool is mounted on the head This is called the cutting tool head, which moves up and down by certain eccentric mechanism or crank and connecting mechanism, and the workpiece shown over here is here, that is mounted on a table. The table is mounted on this flat table, which can move in this direction, one feed slowly. It can move in this direction, this is called feed motion, and in addition to shaping machine where the rotation is not there, here the table can rotate also, or the job can rotate, all right. And basic functions will be very similar again to the shaping machine, because it is nothing but vertical shaper, production of flat surface. But just to remember, it produces small flat surfaces, small grooves, small slots, but all in the vertical plane, and these are all internal features. Say this internal surface, suppose there is a block where a square hole has to be made. So, this square hole. So, these surfaces, vertical surfaces have to be made, this internal surface. All in say slot has to be made. All these internal features are done in slotting machine, because internal features like internal flat surface, pocketing, say grooving and keyway cutting cannot be done in shaping machine. So, this is the basic form. Beside that, some other functions are also there. Some it can be applied, slotting machine can be applied for some few more work, but it is not that versatile, that is to be remembered. It is not neither productive nor accurate nor versatile. Now, let us see the kinematic system and working principles of these various machine tools, shaping machines, planing machines and slotting machines. Now, kinematic system, what is kinematic system? It is a kinematic structure comprising number of kinematic chains. Each chain is responsible for transmitting the power and motion from the source, that is electric motor, from electric motor to the tool or to the job. If there are 3 motions, there should be 3 kinematic chains, and each kinematic chain is again comprised of number of mechanisms, say belt pulley mechanism, then gear mechanism, rack pulley mechanism, worm and worm wheel mechanism and so on. So, this is a very vital part of the machine tools, the kinematic systems, and then we shall discuss how does the machine work with the help of this kinematic system. Let us start from the shaping machine. This is the kinematic structure of shaping machine. Now, look, this is the cutting tool. This cutting tool reciprocates in this direction, and the workpiece that is mounted here on the table, this will move perpendicular to this cutting motion and horizontally. So, if the cutting motion is in the vertical plane like this, so this horizontal plane, the job will be moved in this direction. This is feed motion and this is cutting motion. So, the tool will move in this direction and the job will move in this direction, okay, perpendicular to that, but this will be very fast motion, cutting motion, and feed motion of the job will be very slow. So, these 2 motions are there. Now, the question is how these motions will be attained at the tool and the job. Where is the source? This is the source. Before that, let me tell you the salient parts. This is the machine tool. This is called ram, which reciprocates along with the tool. This is called belt, on which the job is mounted directly or indirectly on a vise, and this is called the column, and this is called the base, which is fixed onto the foundation. Now, this motor rotates, rotation and power goes through V belt into this shaft, through this clutch, it goes into this cluster gears, and ultimately through this gearbox, this is called speed gearbox, comes into this space and then rotates this pinion with the help of this bevel gear. Now, this bevel gear rotates again this bull gear, this is called bull gear. Okay. This is the bull gear, large gear. On the axis of the bull gear, there is a bevel gear, and on that in connection mesh there is another bevel gear. This bevel gear is connected with a screw. The screw passes through a nut, and this nut moves along the slot of a lever, and this lever oscillates, it oscillates like this, it oscillates and about this hinge. So, when this one, this is the say link, this is the link which is hinged over here, and this is the block which is rotated here, this is rotating like this, along with the bull gear. As a result, this will come from here to here. So, this end will oscillate like this. When this will rotate, this block will rotate, the crank will rotate in this direction like along this path. So, this end of this one lever will move like this. Okay. This will move like that. So, this rotary motion, this oscillatory motion will be converted into translatory motion of this one, of the ram. So, this is fixed with this lever, this nut is fixed to the screw is fixed with this ram. So, the ram will travel like this, and on that the tooling head, this is called compound slide, is mounted and fixed. On that this clapper box is fixed. On the clapper box this tool holder, in the tool holder there is a cutting tool. So, along with the ram this cutting tool reciprocates. This is how we get all the motions. Now, this how do we get the feed motion of the job? This is obtained by when this bull gear rotates, along with that there is another gear in mesh. So, this gear also rotates. So, there is a slot, radial slot, on which a pin is fixed, and this is a connecting rod. So, when this rotates, this end oscillates like this. This one oscillates. This is called ratchet pawl system. This is called pawl and this is ratchet. So, this ratchet rotates. Now, it is mounted on a screw. This screw is fitted with a nut, and when the screw rotates, this one moves perpendicular to this plane. So, when the screw is rotated by this one intermittently, so when the bull gear rotates, this one also rotates and this one oscillates. So, this job rotates, this job moves intermittently along with the movement of the pawl. Now, the amount of this amount of movement or the rate of feed will depend upon that how much angle this ratchet rotates, that will depend upon the amount of oscillation. This will depend upon this radial distance, which can be time to time changed, this eccentricity. This is how we get automatic feed. Now, by changing the pawl by 180 degree, we can change the direction of rotation. By changing the direction of rotation, the table can be moved in this way or in this way. So, this is the feed. Now, next question is the control of length and position of stroke. The length of stroke, this is called stroke length. This is called stroke length, all right, not visible, stroke length. Now, how this can increase? This is coming from the reciprocation of the ram. This comes from the oscillation of the lever. Now, if this crank length is increased, then this will be rotating over a wide, oscillating over a wide distance. So, this stroke length will increase. That means, this distance, the crank length has to be increased, the distance between this of this nut from the center. How this can be done? This will be done by rotating this gear, bull gear, this bevel gear, this bevel rotated. When this bevel gear will be rotated by the screw, the nut will move away or towards the center. When this move away, that is, say this is the levers, is rotating like this, the center. When this crank length will be increased, then this circle will be bigger and the oscillation, the stroke length will also increase. Now, this is how it is done. Now, one thing to be noted that it is rotating, suppose in this direction. So, from here to here, when it moves, the crank moves from here to here at a constant speed, the cutting tool moves forward, that is the cutting stroke, and when it moves from this point to this point over a smaller angle, then the tool goes back. This is called return stroke. This angle is smaller than this angle. So, this return will be much faster. So, this is called quick return mechanism, whole thing is called oscillating lever mechanism, and this is quick return effect because of this small angle and big angle, and this ratio of this angle and this angle, that is total time of cutting and return, is called quick return ratio, that saves time. Now, what about the stroke length? Stroke length has been discussed. Now, this position of stroke, this is the position of stroke which has to be shifted from say here to here. This can be done, it can be here, it can be here. This can be done by loosening this nut and then by rotating the screw, and as a result through the nut will be held fixed like that. Through this nut the screw will move. When the screw will move along the screw, this ram will also move forward, little forward, and then you tighten this one. So, by that you can fix the initial position of the cutting tool here or there, and then by rotating this one you can adjust the length of stroke. So, these two things are very important, that control of length of stroke and position of stroke. Then quick return ratio. What is quick return ratio? Quick return ratio is, say, forward time divided by return time. Return time is faster. This is called quick return ratio. This is greater than 1. This will be greater than 1. So, this saves time, and this quick return ratio, this will be equal to 2L plus S divided by 2L minus S. What is L? L is the length of this lever, okay. And what is this? Stroke length, this stroke length. So, when the stroke length is very small, this quick return effect is also very small. So, we lose the benefit of quick return effect. If S is large, the stroke length, then this ratio is quite greater than 1. If S is very close to 0, then this is becoming 1. So, there is no quick return effect. Now, next point is the control of cutting velocity. Now, the cutting velocity, how we control the cutting velocity? Cutting velocity denoted by Vc will be equal to length of stroke, that is S, by number of strokes per minute, and this is the total length divided by or equal to 1 into 1 by Q. Q is the quick return effect. So, stroke length and Ns. Now, the quick return ratio is more or less fixed. Now, if we want to increase the velocity, we have to increase either stroke length or this number of strokes per minute, the reciprocating rate, how many reciprocation occurs in 1 minute. Now, the stroke length is decided by the length of the job. So, for controlling the cutting velocity, better you control the number of strokes per minute. So, how do you control it? Now, here you see that when the power comes from the motor through this one, there is a gearbox. There is a gearbox. This gearbox called speed gearbox, by operating the cluster gears with the help of levers, we can increase or reduce the number of strokes per minute or speed. And feed, how do you control? Feed we control by controlling the length of this one, this eccentricity. This will control the amount of oscillation and the amount of rotation of this feed rod or movement of this one. And again, this tool can be moved downward also by operating this wheel, or this bed can be raised as and when required for vertical feed or for placing the job appropriately related to the tool by rotating this wheel. So, when you rotate this wheel, this bevel gears will cause rotation of the screw, and the nut will move. This nut is a part of this whole thing, and the whole bed will move upward or downward depending upon the direction of rotation. So, all these things are the pertinent for the shaping machine. Now, kinematic system of and working principle of planing machine. How does planing machine work? Planing machine suppose this is the table, this is the work table which has got V projection, and then it is resting on bed and resting on the V, and this is the long one, is the bed, and this bed reciprocates in this direction, okay, on this guide. Now, how at the bottom surface here, suppose this is the bed, okay, and there is at the bottom of the bed there is a rack is fitted, the long rack is there at the bottom, and that is in mesh with a pinion, okay, and this pinion is rotated. When the pinion is rotated, then this rack will move either in this direction or in that direction, depending upon the direction of rotation of this shaft. Now, on this shaft there are gears. Suppose there is one gear, large gear, and there is one small gear like this, okay. And there is loosely mounted, and there is one idler, and there is one gear, there is one gear, this shaft. Now, here you see there are two gears only, 1 and 2, and there are 3 gears, 1, 2, one idler is there, and so one idler is there, and this 3. So, the direction of rotation of this gear and this gear are different. Now, when these two gears will rotate, this shaft will not rotate, but if there is a clutch, suppose there is a clutch, and this clutch can move connected with this, with the spline connected with this shaft. So, when this clutch will be engaged with this gear, then this will rotate in a particular direction. When this will move in this direction, then the direction of rotation will change. Now, how will you get quick return effect? This is a small gear, this is a large gear. So, this shaft will rotate at lower speed. So, this will be engaged with this one for the cutting stroke, that means when this will go in this direction, that is called cutting stroke. And when with the return stroke, this will be connected with this one gear, this clutch, and then this is rotating faster. So, the return will be much faster, and this clutch will be operated by some mechanical locks or stops. Suppose this is the table, this is the table, and that is moving on the bed. On the bed there is a lever like this, and there are mechanical stops here. These are fitted 2 pieces. Now, this end will be here, this end will be here. So, when this table will move along with the job, this will strike here and this will incline like this, and when this will strike here, this will get inclined like this. That means, these 2 stops will strike here and this end will move either this way or this way. When this will move in this way, then is a cutting stroke. When this will move in this way, then immediately the return stroke will stop. So, these 2 stops will control the direction of travel, control travel. And how do you control the length of travel? By the distance. These 2 stops can be put here or here with a larger gap or closer, and that will decide the length of stroke. How will you decide the position of stroke? Position of stroke, this one you can shift it here, this one you can shift it here without changing the gap. So, by shifting the position of these 2, we can change the position of stroke, and by changing the gap between these 2 stops, we control the length of stroke. This is how it is actuated. And then the feed motion. The feed motion, this is the tool. Suppose this is the tool in a planing machine. This is the cutting tool, and this is the workpiece mounted on the table, and that moves on the guide bed, and this is the mount to the table. Now, there is a screw, okay, and when the screw rotates, there is a nut. So, when the screw rotates, then this will move in this direction or in this direction, and this rotation is connected to the movement of the table. So, when the table moves reciprocate, this also intermittently rotates by ratchet pawl mechanism, and there may be number of tools, 2, 3 number of tools, and this one is mounted on 2 vertical levers, and this entire thing can be moved by set of screws upward. So, the cutting tools can be moved in this direction, or in this direction horizontally by rotating the screw, and the whole thing, the tool can move upward and downward by rotating these screws, all right, by a pair of bevel gear here and a pair of bevel gear here. This will be rotated. So, the whole rail can move up and down, and it can on the rail, these 2 tools or number of tools can move up and down. So, there can be tools on the side also, from the side, which will move up and down and do the machining work at the side of the job. So, these are the various principles of planing machines. Now, see the slotting machine, kinematic system and working principle of slotting machines. Now, this is the configuration of slotting machine. Now, again identify, you see, you always start from the tool. This is the tool, okay? This is the tool. This tool moves vertically up and down, this moves up and down, and this is the workpiece which is mounted on the table, rotary table, which is mounted on another block or slide, which can move in this direction as well as in this direction. So, this is a y and this is x, or so you can say this is x longitudinal and this is a y cross feed, and in addition to that the table can rotate also. Anyway, so this cutting tool reciprocates just like shaping machine. In shaping machine the tool reciprocates in horizontal plane, but in slotting machines in vertical plane, and the workpiece moves along x axis, along y axis, or it can also rotate. Now, how these are accomplished, how the movements are accomplished. So, let us see first how this tool can be reciprocated. Come to the power, this is the source of power, then power goes from the belt pulley into this shaft. What is the most important shaft? Called driving shaft. Onto the driving shaft there is a disc, on the disc there is a slot and there is an eccentric mechanism and there is a connecting rod. So, when this rotates, this connecting rod oscillates, and this is the crosshead which is connected to this top slide. So, when this rotates, the top slide moves up and down just like crank and connecting rod mechanism, this is crosshead, and this slide which moves vertically up and down along the guide has got one clapper mechanism in which the tool holder is fixed. Into the tool holder the cutting tool is fixed. So, when this rotates, the shaft rotates, this cutting tool moves up and down. Now, rotate this feed motions. Now, when this shaft rotates, from the shaft the rotation is transmitted into this disc by bevel gears. When the disc which has got also slot and there is an eccentric mechanism. So, there is a 1 bar, second bar, third bar, fourth bar, it is basically a 4 bar mechanisms. So, when this disc rotates, this end, this lever or this oscillates like this. So, this one also oscillates, just like the ratchet pulse system we use in shaping machine. So, this shaft will rotate, this gear will rotate intermittently, and that is connected with the bevel gear. So, this will rotate intermittently. So, rotation of the shaft will transmitted into rotation of this one, but this will rotate intermittently. So, when this rotates one, this rotates slightly. Now, this rotation of this shaft called feed rod is transmitted to another screw called lead screw. Now, when this lead screw rotates, the entire block moves forward and backward, and this is connected, this motion is connected to through bevel gear rotation of this wheel. Now, when this wheel is engaged with this wheel, which is nothing but a gear fitted into the screw that gives this table, the upper slide, x motion, feed motion, and when this is engaged with this gear, this is connected to the worm, that is connected to the worm wheel inside, that makes this job rotate, all right. So, this rotation of this one or rotation of this shaft causes intermittent rotation of this shaft feed rod, that helps you can move this one. So, this will move forward and backward by a clutch, or you can engage this gear with this gear, then we get cross feed, or when this will engage with this worm, then because of the worm wheel rotation the job will rotate slowly. So, all these 3 feed motions can be attained. Now, have a look into the controls. Control of length of position of stroke. Now, length of stroke, this length of stroke can be controlled by changing this distance, this eccentricity. But if you increase it, the stroke length will increase. Then control of position of stroke. Now, here this arrangement is very similar to shaping machine. By rotating this one, the position of the screw with respect to the nut, this gear also behaves as a nut, will change. As a result, keeping this one fixed, this ram, or not the ram but the head, will move forward or backward. So, this way we can adjust the position of the tool in advance, and then by controlling this one we can control the length of stroke. Quick return effect, there is no quick return effect because the mechanism is not oscillating lever mechanism. Quick return effect exists in shaping machine and planing machine, but in slotting machine it is not there. So, it is 1. And control of cutting velocity, will be governed by the length of stroke, but that will be decided by the stroke required job and the number of strokes per minute, that is NS. So, this will be decided by, that can be changed by the rotation RPM of this shaft by changing the gear pulley, belt pulley. You can change this pulley, or there can be one speed gear box here to operate, to change the speed of rotation, that will help changing this one. So, this is how this slotting machine works. Now, the machining applications. This is the most salient part for manufacturing process, because we have to produce jobs. So, machining applications of these 3 machine tools of reciprocating type. I already told that these these are reciprocating type, used mostly for making flat surfaces and some other features bounded by flat surfaces. Now, what are the applications of shaping machine, planing machine and slotting machine, which will be very similar. Let us see the machining operations done in shaping machines. General applications, the 2 category, general applications and critical applications. These are most common. Producing flat surfaces, all right, flat surfaces in horizontal surface, horizontal plane, vertical plane or inclined plane. Features bounded by flat surfaces like a slot. Suppose we want to produce a slot like this. So, this slot will be bounded by one surface, another surface and another surface. So, 3 flat surfaces constitute this slot. Curved surfaces, if we want to make a groove like this, so this is called curved surfaces by form tools. So, these are the various things. Now, we shall and critical applications will be shown later on, discussed, that using special attachments. As I told you that shaping machines, all the machine tools are used for, all these 3 machine tools for making basically flat surfaces, especially shaping machine. Now, machining application of shaping machines, production of flat surfaces. Now, here you see production of flat surfaces. This is the flat surface, this is the tool which reciprocates. Now, in shaping machine you can see the tool is always reciprocating in all applications in horizontal plane. Now, we want to remove this material and make this flat surface on this job. So, this is the flat surface, okay. This is 3D and like this. So, this is the motion and the job will be fed in this direction, we produce this flat horizontal surface. Then we want to make this vertical flat surface, there the cutting tool has to move reciprocating like this and the feed motion will be given to the tool and this will gradually move down and remove this material layer by layer in the form of chips. So, first chip, the next chip, like this, all the layers will be removed and we get a flat surface, vertical. This can produce inclined surfaces also. Here you see this is a dovetail guide, we want to make this surface. So, the cutting tool has to be held. So, the cutting tool has to be held not in a vertical position, in an inclined position. So, this swiveling is possible in shaping machine. Now, this will reciprocate forward and backward. Okay. So, this cutting tool is held with a little inclination, this is called clearance angle and this is a rake angle will be there, this is a rake angle has to be there and then this has to be moved along this axis, along this surface, it has to be moved, that is called feed motion, but this is the cutting motion. Internal surface say for the same dovetail guide, this is the guide, this is the slide and you are want to make these surfaces, this has to be done by this and here also the tool will reciprocate and the tool will be held in inclined fashion, and this will gradually moved in this direction to remove this material. Similarly here, and we get the entire surface. Machining applications of shaping machine. Next is features bounded by flat surface. Here you see that this is a slot, this is the block, this is the block like, and we want to make one slot like this, a slot. Now, this will be done by this shaping tool, and first of all this was flat, now layer by layer material will be removed. So, this material will be removed layer by layer. So, this tool will reciprocate first, layer, remove a layer, then the tool will be moved slightly down, that is called feed motion, this is a feed motion, then this motion will be repeated, you remove another layer. So, you continue this cutting motion and this motion, and then you get this slot. Remember, this feed motion is intermittent and this is reciprocating. This is the forward stroke, cutting stroke, this is the return stroke. After the tool comes over here at the end of the return stroke, only then this feed motion is given by a little amount, and then it remains stopped. Then layer is cut, the tool comes back, again it is given a feed motion. Now, if you want to produce a pocket like this, now say wider, this is a slot, this is a wider slot. Suppose we want to make a part like this, So, a pocket. So, how do you start? You have to start, this is a cutting tool which has to first cut a slot like this, okay, and then this will be removed, moving by in this direction, giving feed, and then you travel this job in this direction. So, tool will advance and remove this material. So, the entire material will be removed. Now, this is example of cutting the T slot. This is a T slot in the machine tools, and this is a cutting tool which will be first started from here. First this slot will be made. Now, let me show you that suppose this is the workpiece. Okay. So, first you make a slot like this. So, this slot, and then entering the tool. So, this is the tool, you now move the job in this direction. That means, this tool will gradually enter here, then you reverse it, the tool will reverse and make this slot here. So, ultimately you get the T slot, this T slot. So, here also this cutting tool is reciprocated in this direction, this is feed, and this tool will be reciprocating perpendicular to the axis. Now, this shows making a V block. This is a V block. What are the surfaces, important surfaces? This is one surface, this is the V surface which are machined, these surfaces, these slots. Now, this tool will move in this direction, this feed motion. Remember, the cutting motion is always there perpendicular to the job, this is moving, and because this is the cutting motion. So, the reciprocation will be always there, all the tools will move perpendicular to the plane shown over here in this direction, and these arrows shown over here, these are all feed motions. So, this will fade in this direction, this will fade in this direction, this angle has to be maintained for clearance, this angle for clearance, and this tool will make the slot, and this tool will gradually move upward and remove this material layer by layer. This can move upward, this will also move upward and remove the material layer by layer. So, all these surfaces can be produced in this fashion. Machining applications of shaping machine, that is machining of curved surface. This is a curved surface, that means suppose this is the block in which we want to make one curved surface, a curved group like this. This can be oil group or for some purpose. In that case, the cutting tool, this has to be a form like this cutting tool. So, this cutting tool start like this, then it will remove the material gradually. This tool will gradually move down, layer by layer the material will be removed, and this will come to the final position, and then this motion of the tool will produce the job. Here the job does not move in this direction, the tool is feed in this direction or job is raised in this direction, and you get this form. This is called form, and this kind of tool is called form tool. Okay, form tool. Now, observe that in shaping machine, planing machine, in slotting machine, all these machine tools, all the tools are single point tool only. So, productivity is much less, but this can be form tool or it can be single point tool. Now, here is another example, say cutting the teeth. Actually, we do not cut the teeth, what we cut? We cut the remove the material in between the tooth. So, this is the cutting tool, this is the cutting tool, this will reciprocate in this direction, and this is the workpiece held, and then this tool will remove, gradually move down and remove the material layer by layer, but the form of the tool will produce the form of the tooth gap. So, this is how. Now, after that this will be rotated by one tooth gap and you can make another tooth. So, indexing is necessary. So, this is one application of gear making, but remember that really the gears are not manufactured, these are manufactured by this machine. This is a very slow working machine, only for repairing work, one or two teeth can be cut for repair work and maintenance work, but not for mass production, because the process is neither very productive nor very accurate. Some special applications of shaping machines: cutting the slit in screw head. These are done using some, this is the screw head, suppose these are small screws made by some machine, and there are some slits are made, okay, for the use of the screwdriver. These slits are made in shaping machine, and that for that one attachment is necessary for quick production. Now, thread rolling using flat dies. Now, thread rolling, so there is a die with a thread and there is a workpiece blank, and this is another die with a thread, all right, and this is stationary and this will be moving in this direction, and this part of the screw will remain inside, and when this will move, the threads that is here, because on the side surface there are threads, here also there are threads. So, these threads will produce a thread on this piece. So, there will be thread produced, and this can be done in shaping machine with a special attachment. Cutting internal keyways, yes, it can be cut, but with little difficulties. Suppose this is the workpiece and this is the gear blank and one keyway has to be cut, then the cutting tool has to be like this, which has to be mounted. So, this is the shaping head. So, this will reciprocate, and the cutting tool is a L type that will produce. Teeth of small racks, splines can also be done, but these are all external racks. Rack is always external, splines internal, not internal, external splines are made. Now, come to machining applications of planing machine. Here suppose this is the what are done in planing machines, all those work done in shaping machine can also be done in planing machine. Salient surfaces and guideways of large beds. Now, this is example. This is a bed of a machine. Now, this surface are to be machined. Okay, this surface are to be machined. Now, this such a big job, maybe 2-3 meter long, have to be machined in a shaping machine. This one, this tool, these two tools, and these two tools, 4 tools will move will reciprocate for the cutting action perpendicular to the plane, but they will feed motion in this direction. All of them will move simultaneously and remove these materials and make these surfaces flat. This tool and these 4 tools will move vertically down, all of them simultaneously, and they will produce the flat surfaces. So, this way many applications are there for making the beds or tables of machine tools are done in this way. Salient surfaces and good tables. Now, V and inverted V guides are also T slots also made in say planing machines. Special applications using special attachments can be done, say some carved surface can be made, some if there is a rod, in the rod if you want to make a helical groove, then that can be done in a planing machine with special attachments that you can see book. A lot of examples are given. Now, come to machining applications of slotting machine. In slotting machine, the work is vertical always. So, this is the job. The tool is reciprocating the vertical direction, all right, and that is removing this material. So, this is a block where the rectangular slot has to be cut, bounded by 4 flat surface, but vertical flat surfaces. So, this will move in this direction and the job will move either in this direction or in this direction gradually. So, this is one application. So, internal flat surfaces, most of the work are internal, which cannot be done in shaping. Now, enlarge and finish non-circular holes. So, these are non-circular holes. If you want to finish or enlarge, then this is the process. Now, making blind geometrical holes. This is a hexagonal hole and up to this much, not through. This is a socket, basically a socket used to operate nuts and bolts. So, this can be done by moving this tool vertically up and down, and there is a recess made in advance, so that it does not disturb, and this is the material removed. After removal, finishing this surface, then tool will be withdrawn and the job will be indexed by 1/6 of a revolution, and this surface will be brought here. So, in this way all the surfaces will be made. The tool will be in one position, but the job will be rotated. Internal grooves and slots. Internal grooves and slots, suppose this is a disc and hole. So, you want to make a slot here, it is a keyway. Then internal keyways, splines, gear teeth. Yes, internal gear teeth can also be cut, but in small scale, either 1 or 2 pieces. Oil grooves, all are internal. Now, future of shaping, planing and slotting machine, this has to be learned, because we have already covered lathes, which are productive machines, and drilling machine, milling machine, these are all productive machines used for batch production, piece production, lot production. But shaping and slotting machines especially are not used for regular production and going to be almost obsolete because of their poor performance. Why? Because there for very low productivity, productivity is very low, process capability, accuracy is also very low, versatility, range of activity is also very limited. But why are they so? Due to why the productivity is low? Due to large idle time, return stroke is idle. So, huge wastage of time, low cutting velocity, because it is a stroke like, impact like. So, velocity cannot be high, lack of rigidity of the machine tool. So, we cannot give large feed, large depth, and the job will undergo deflection, deformation. So, both productivity and process capability will be lost. Absence of automation, that also reduces the productivity. Use of only one cutting tool at a time. In shaping and planing, shaping and slotting, a single point tool, that reduces the productivity, and constraints by configuration also do not allow versatility. Now, planing machines, these are little more versatile and more productive than shaping and slotting machine, because they are rugged and rigid and many operations can be done. But planing machines are also getting replaced by plano millers and plano grinders. Instead of single point tools, milling cutters, large number of milling cutters, if required grinding wheels are also used for finishing. So, single point used in shaping planing machine are becoming obsolete. All shaping machines are now converted, or from inception plano millers and plano grinders are used. Shaping machine using single point tool are becoming almost obsolete. Now, after going through this lesson, you can practice. I have given some exercise, 10 exercise. These are like this. There are 4 options, and you have to select on the correct answer. Say reciprocation of the cutting tool in shaping machines is accomplished by which one? So, there are 4 options, you have to select the correct one. Now, look, so reciprocation of the cutting tool in shaping machine. Now, rack pinion mechanism, no, that is for planing machine. Crank and connector mechanism, no, that is for slotting machine. Cam and cam follower mechanism, no. Oscillating lever mechanism, yes. So, you have to tick select. So, this way internal keyway in gears can be cut. There are 4 options: internal keyway in gears, okay, this is internal work. So, be careful, can it be done with shaping machine, planing machine, slotting machine, none of the above. You understand that slotting machine is the answer. Now, this way you can practice all these 10 questions and all the answers will be given in the next lecture. So, you can check your answer from the next day's lecture. Okay. Thank you. Now, we are going through module 4, that is general purpose machine tools, and now lecture 4.5, mounting of jobs and cutting tools in machine tools. These will be taken in 2 parts, part A and part B. Today in this lecture we shall cover part A, in the next lecture we shall cover part B, because it is a bigger course. Now, the specific instructional objectives as a whole of this lecture material. This will enable the students state the principles and conditional requirements of mounting jobs and tools in machine tools. Now, here you see that the performance of machining system is very much affected by, or indirectly you can say that the perfection of mounting of job and the tool play very important role on the perfection of the working of the machining system. Therefore, if you want very good machining performance from the system, then the cutting tools and job have to be mounted very carefully, judiciously, methodically and accurately. Now, this part is state the principles and conditional requirements of mounting jobs and tools in machine tools. These conditions have to be fulfilled to get good performance for the machining system. This course will also enable this lecture illustrate how the jobs and tools are mounted in different machine tools like lathes, drilling machines. Now, up to lathes and drilling machines will be covered in this lecture. In the next lecture will be covered part B, shaping, planing and slotting machines like reciprocating machines, milling machines and grinding machines. Then next day it will also cover, point out requirements and show methods of mounting jobs and tools